9.1 is on graphing sine. And one thing that you will notice about Unit 9 in particular is that everything you learned in Unit 8 about the unit circle, about finding the sine of something or the cosine of something or the tangent of something or the secant or cotangent, all those 6 things that we did with the unit circle are going to show up throughout Unit 9. If you are not good at finding those ratios quickly, then I would recommend going back to Section 3, maybe even 4 and 5 from 8 and learning those 2 things. So what I'm going to do is I'm going to talk to you about finishing Worksheet 1 and part of Worksheet 2 in these set of notes. This should be able to take you up all of Worksheet 1, and you could even do the first 5 problems of Worksheet 2. What we're going to be doing is we're going to be plotting the sine function and the cosine function separately. When you think of the unit circle right now, you're thinking of a circle with angles and x and y coordinates. Well, what if the angles were the variable? What would the y values be for those questions? What would that graph look like? And so you're going to figure that out in Worksheet 1 and 2. And I'll give you a hint about that in just a little bit. But first and foremost, as you do Worksheet 1 and Worksheet 2, having different color pens and pencils will be helpful, especially on numbers 2, 3, and 4. When you do number 1 on Worksheet 1, you're not going to notice it. You can do this in pencil. When you get to problem number 2, which is on the back side of the page, it's going to say choose a different color. And so if you have a red pen or a blue pen or a green highlighter or a yellow highlighter, that will help you to distinguish between which functions you're drawing. So you can see the differences in them. So that will be helpful. If you are a person who doesn't have a bunch of different colored pens on you, I have some green pens in here. If you have a red pen and you want to switch with somebody else, I would recommend doing that today. The other thing that we're doing, because we're dealing things with as functions, the angles like 0 and pi over 6 and pi over 4 and pi over 3 and pi over 2 are going to be our inputs. What if those are on our x-axis? What would the graph look like? The ratios, when we talked about root 3 over 2, root 2 over 2, 1 over 2, 0, and 1, and all those ratios, those are going to be our outputs. What would that look like? And I'm going to give you a little bit of a preview of what you're going to see today. This here is an animation of a circle graph that is measuring the distance from this point on the outside of the circle, and it's saying how far is that point away from the x-axis. When you look at this animation and how it finds the distance, how far is it from? How far is it from? How far is it from? It creates something that looks like this. This wave is called the sine wave. You will learn what the sine wave looks like and how to graph it, and it's based off of a circle, just so you are aware. Few things when we do this worksheet. Make sure that you round to the nearest tenth. There's no reason for us to do anything otherwise, which means you will need a calculator at points when you're trying to figure out what is root 2 divided by 2. Well, even though it's really, really long, just round it to the nearest tenth, about 0.7. Root 3 over 2, what is that about? It's about 0.86, but we'll round it to about 0.9. And, of course, we'll figure out the other ones. Okay? I'm not sure if you're going to need this, but they will ask you questions. I'm going to leave that there for you. And here's how it works. On worksheet 1, you're going to have 16 boxes. I've only shown you 3. On your graph paper, you're going to have at least all the way out to 2 pi. I've only shown you the first part. This is just to give you an example of what you're going to do on your own with your partner today. Here's how it works. If your angle was 0 radians or pi over 6 radians or pi over 4 radians, the sine of 0 radians, if you remember, is this value. The sine of this as a fraction, if you remember, it's this. The sine of this is... So if you remember those as a fraction, you put that in the first column, but then it says what is it as a decimal. So this is really easy. 0 as a decimal is 0. 1 over 2 as a decimal is 0.5. We just wrote down that root 2 over 2 is about 0.7. So you fill in your chart. You're going to do the whole thing. Sometimes there's going to be positives. Sometimes there's going to be negatives. Don't let that fool you. And then there's going to be this graph paper that says if this is your x, and this is the output, you're going to put a point over here. So 0, 0. For my first coordinate, you put a dot right there. At pi over 6, you should have a y coordinate of 1/2. At pi over 6, you go up to 1/2, you put a dot. At pi over 4, it's supposed to be about 0.7. You're going to have to kind of guesstimate. Let's see. 0.5, 1, 7 is going to be not more than halfway. It's going to be a little less than halfway. But right above the pi over 4, you put a dot. And so on. And you're going to end up with a bunch of dots. And you're going to, eventually, it's going to tell you connect the dots in this fashion. You'll figure that out. And then you will answer a variety of different questions in the worksheet. Don't forget to read the worksheet. It tells you basically what to do. And that is where we're going to end our notes.